Welcome to the Air Pollution Monitoring Project. This is a collaboration between DSSG-Solve and UNICEF. In this project, we aim to combine air quality data from remote sensing and ground observations to answer if children's respiratory health has improved due to COVID-19 imposed lockdowns, and if so, by what extent. Children are among the population groups most vulnerable to air pollution. Millions of children suffer from air pollution-related conditions every year, and in 2016 alone, 500,000 children all over the world died due to such conditions. As you can probably gather, air pollution significantly affects the growing respiratory system of children and causes short-term issues like coughs or respiratory illness to long-term consequences like brain damage and lung, heart, or hormonal disorders. We have observed drastic changes to air pollution levels due to COVID-19 related lockdowns across the globe. For example, in areas surrounding the Chinese capital Beijing, we see a significant reduction post-lockdown. This is important because air quality around the home or school of a child can affect their health. However, accurate air quality information is scarce, as weather stations are generally located few and far between. Because of this reason, we took the following approach to fill in the gaps in air quality information data in order to answer the original question we started with. We use machine learning to cross-calibrate between two data sources: remote sensing data that's more available and ground observations data that's more accurate. We shall produce a dashboard to aid in exploration of this more complete data set by UNICEF officials. Following this, we aim to perform the actual impact analysis, which means correlating child health indicators to air quality information. We're using data from 3 countries, Vietnam, Peru, and South Korea, to facilitate implementing the results by leveraging the tie-ups UNICEF has with the local governments. We use publicly available remote sensing data and ground level data from multiple sources, such as OpenAQ from our partners in UNICEF, and also from Plume Labs, which is an air quality monitoring company. Other sources of data include several features related to lockdown information, as well as several sources of demographic data, such as school location, child population, and land cover. Going a bit into some results, comparison of ground level air quality from weather stations across Lima, the capital of Peru, replicates known patterns. As we can see from the plot, there is a clear drop in PM2.5 concentrations pre and post lockdown. Notice that we do not always have readings from all weather stations. We plan to smooth over this heterogeneity using our calibration method. Comparing air qualities from the 2 different sources for the same variable PM2.5, we see that readings follow similar distributions. Although the tails of these distributions show some discrepancy, the readings mostly agree. In the coming weeks, we plan to build on these initial results to get a more complete picture of air quality across space and time in our target regions. To wrap up, as a member of this project, I have had the pleasure to interact with a talented group of people from all around the world and learn from them, while also tackling a problem with real-world impact and using my expertise to give back to the community. Also, a shout out to our partners who have brought significant subject matter and technical expertise to the table. We collectively thank Solve for Good for this opportunity. Please feel free to reach out for any questions. Thank you.